Hello everyone, go ahead and split your notebook into about 6-7 sections, and the title for today is Building the Unit Circle Coordinates. So the first thing we need to talk about is the unit circle itself and where it got its name. The unit circle is called the unit circle because it is a circle with a radius of 1 unit. I'm going to go ahead and draw an example of a unit circle. And it's telling me that the radius, and remember that the radius is the distance from the center to the edge of the circle. This area is equal to 1. And it's not only the horizontal and the vertical distances that are also equal to 1, but any line that you draw is going to be 1. So any of these distances would be equal to 1. Now, this means that if I were to create a reference triangle on the unit circle, the hypotenuse of that reference triangle must be equal to 1. And let me show you an example of this. So again, recall, let's say I had my unit circle, and this distance is equal to 1. If I want to create a reference triangle, I would need to graph an angle, connect it toward the x-axis, right? And it's telling me that the hypotenuse, which is this distance on my triangle, is also the same as the radius. So the hypotenuse needs to be equal to 1. And this happens regardless of where I draw my triangle. An example, let's say that this is my unit circle. Let's say that I draw it here. Right? Again, this is the radius of 1. And once I create my triangle, that radius is also the hypotenuse of the triangle. Okay? Now, we can use special right triangles for the reference triangles on the unit circle. However, the hypotenuse, again, must be equal to 1. Okay, so if I'm going to use reference triangles on the unit circle, I need to make sure that I change the hypotenuse or alter it so that the hypotenuse is equal to 1. Currently, on special right triangles, the hypotenuse is 2. So we must divide all sides by 2 to create a hypotenuse of 1. So let me show you what I'm talking about. This is a special right triangle. This is a 45, 45, 90 triangle. And like we just talked about, if I'm going to use this triangle on the unit circle, the radius, which is also the hypotenuse, this distance here needs to be equal to 1. And the problem is that right now, the hypotenuse is equal to 2. So in order for this hypotenuse to be equal to 1, I will need to take the value of 2 and divide by 2. But if I do that to one side, I need to do that to all of my sides. So once I simplify, 2 divided by 2 is going to give me 1. And then radical 2 over 2, I can't really simplify anymore. It would stay as radical 2 over 2. Okay, so moving forward, when I use a 45, 45, 90 on the unit circle, I'm no longer going to use these labels to the left that we've been using. Instead, I have to use these labels to the right. Okay? Now, the same thing happens with a 30, 60, 90 triangle. Notice how my hypotenuse is equal to 2. And I need my hypotenuse to equal to 1. So same thing, I'm going to divide by 2. 2 divided by 2 is 1. And I need to do that to all of my sides. So if I simplify 2 divided by 2, I get 1. My 1/2 stays as 1/2. And then I have radical 3 over 2. So moving forward, I'm going to be using this triangle here when I'm working on the unit circle. Now, this is also a 30, 60, 90, but instead of it laying on the longer leg, making it shorter, it's currently laying on the shorter leg, making it taller. And so we're going to do the same thing. Divide everything by 2, making my sides radical 3 over 2 and 1/2. Okay? So in sum, these are my 3 triangles and the labels that we're going to be using. A 45, 45, 90 will now have these labels on the unit circle. A 30, 60, 90 triangle will have these labels on the unit circle. And the same triangle but rotated will also have similar sides labels on the unit circle. Before we can begin to build the unit circle coordinates, we need to be familiar with all of the quadrants in the XY axis. So here is a label of all 4 quadrants that divide the Cartesian plane. I have quadrant 1 in the top right corner, then quadrant 2, 3, and 4 going in counterclockwise direction. What's important to know about these coordinates is the signs of each coordinate. So when I'm in quadrant 1, let's take this point for example. This would be the coordinate 4, 3. My x value of 4 is positive and my y value of 3 is also positive. And this is because I'm going in the positive x direction and in the positive y direction as well. Now let's take a coordinate in the second quadrant. Let's say, for example, I have a point here. This would be -6 and 3. So as you can see, your x now becomes negative in the second quadrant and y remains positive. Let's go down to the third quadrant and let's say I choose this point here. This is -5, -2. So both x and y are negative in the third quadrant. And let's choose this point for quadrant 4. This would be +7, -3. So x is positive and y is negative. And this is any time that we are in these quadrants that these rules will apply. Always. Okay, not just for these specific points, but any point that you choose in the fourth quadrant, you're going to have a positive x and a negative y. Okay? So, moving on. If I had, for example, 30 degrees graphed on the Cartesian plane and I needed to create a reference triangle, I could use the special right triangle of 30, 60, 90. And because I'm on the unit circle, where the radius needs to be equal to 1, I'm going to use a special right triangle that has the labels 1/2, radical 3 over 2, and 1. And so let's say, for example, this is where I am, and I want to find what is the cosine of 30 degrees. Well, the cosine, I would need to label all of my triangles first as opposite, adjacent, and hypotenuse. And I know that cosine is adjacent over the hypotenuse. So the adjacent is radical 3 over 2, and the hypotenuse is 1. So radical 3 over 2 divided by 1 is still radical 3 over 2, which, if you notice, is simply the a value or the x value. So because my hypotenuse is 1, dividing by the hypotenuse is not going to change anything. So the cosine winds up being the a value, which is the x value on the x-axis. So I can say that cosine is the same as x. And if I were to repeat this with the sine, well, let's see what happens. I would get sine of 30 is opposite over hypotenuse, which is 1/2 divided by 1. And my answer winds up being 1/2, which is only the opposite. And so I can say that sine is the same as O, which is the same as the y value on the unit circle. So I just wanted to give a really brief proof as to why x is cosine on the unit circle and y equals sine. This is obviously something that we are taught in Algebra 2 and Pre-Calc, and you've probably heard before, like, oh, when you're on the unit circle, the x coordinate of the coordinates on the unit circle, the x value is cosine and the y value is sine. But a lot of times we don't know why that is, right? So I just want to, again, give a brief review. Now, given that we know x is cosine and sine is y, this helps us to determine which trig functions are positive and negative for each quadrant. So remember that we just talked about the signs, right? This one being positive, positive, negative, positive, negative, negative, and then positive, negative. And we also know that the first coordinate is cosine. My apologies. And the second coordinate is sine. Now, using this information, I'm able to determine which trig functions are going to be positive. In the first quadrant, let's zoom into the first quadrant here. Sine is positive, cosine is positive. Now, this also means that their reciprocals, secant and cosecant, are going to be positive as well. And if I wanted to find tangent, remember tangent is sine over cosine, positive divided by positive. Tangent would also be a positive value, and that would mean that tangent is positive and cotangent is positive. And that is why all 6 trig functions are positive when I am in the first quadrant. Okay? And so here you can see that all trig functions are positive in the first quadrant. Okay? Now let's look at the second quadrant. If cosine is negative, that means its reciprocal of secant is also going to be negative. If sine is positive, cosecant will be positive. And now let's determine tangent. Remember, tangent is sine over cosine. So sine is positive, cosine is negative. Positive divided by negative is negative. So that means that tangent and its reciprocal of cotangent are negative. So what is positive in this quadrant? Well, the only ones that were positive were sine and its reciprocal. Okay, now let's look at the third quadrant. Cosine is negative. That means its reciprocal is negative. Sine is negative, meaning its reciprocal is also negative. And if I wanted to solve whether tangent was going to be positive or negative, I do sine negative over cosine negative. And negative divided by a negative is a positive. So the only functions that are going to be positive in the third quadrant are tangent and cotangent. Lastly, let's move on to our last quadrant, fourth quadrant. If cosecant is positive, its reciprocal is also positive. Sine is negative, meaning cosecant is negative. And if we want to find tangent, tangent is going to be sine over cosine, giving me a negative value. So what winded up being positive? Only cosine and its reciprocal. So how could I create an acronym that's going to help me figure which ones are positive in each acronym? Well, in the first quadrant, all are positive. In the second quadrant, sine and its reciprocal are positive. In the third quadrant, only tangent and its reciprocal were positive. And in the fourth quadrant, only cosine was positive and the rest were negative. So all STC. And there is an acronym that we can use to remember which ones are positive in that quadrant. All students take calculus. All meaning all 6 trig functions. S meaning sine and its reciprocal cosecant. T meaning tangent and its reciprocal cotangent. And C meaning cosine and its reciprocal of secant. Okay. Now, let's actually get into building the unit circle coordinates. So now that we have all of the angles on the unit circle, which we did in another video, we need to figure out what are the actual coordinates of each of these angles. So we're going to look at the quadrantal angles first. I'm going to look at 0, pi over 2, pi, 3 pi over 2, and we know that 2 pi is in the same place as 0. So, in order to figure out the coordinates of a quadrantal angle, you need to recall that this distance is the radius, and the radius for the unit circle is equal to 1 unit, which is 1. So pretend, or not pretend, it's actually that this center is the point 0, 0. Okay? So if I'm at 0, 0, and I move 1 unit to the right, this coordinate would need to be, I moved 1 on the x and I didn't move up or down on the y-axis. Okay? This is where I'm at. So this coordinate is 1, 0. Now, let me try to figure out the coordinate at pi over 2. Well, I'm at 0, 0. And I'm going to make this a little bit darker. I'm at 0, 0, right? And instead of moving to the right, I'm going to be moving upward pi over 2. And so I didn't move left or right on the x-axis, so that's 0. And I moved 1 entire unit up. So that coordinate is going to be 0, 1. Okay. Now let's figure out my coordinate at pi. I start at 0, 0, right? That's where I'm starting. And instead of going to the right on the positive x-axis, I have to go to the left. And going to the left, is that positive or negative? Going to the left is negative, and I'm going to go a distance of 1. And I'm not moving up or down, right? Okay. And now I have 3 pi over 2. I am not moving any distance. If I start at 0, 0, I'm not going to go left or right, but I am going to go down 1 unit. So this is how I'm able to find the coordinates of any quadrantal angle. And again, if I wanted to find the cosine of that angle, I use the first coordinate, and to find the sine, I use the second coordinate. We're going to start actually finding some of the coordinates of angles that are not quadrantal angles, angles that fall inside of a quadrant. So here I have 30 degrees, which is pi over 6. And I know that if I wanted to find the cosine, I would need the x value, and sine is the y value. So for cosine, because I know that this value is x, I'm going to look at what is the value that is parallel to the x-axis. So here's my x-axis, and that value is radical 3 over 2. So I'm going to say this is radical 3 over 2. And to find the sine, I know that the sine is the y value. So I'm going to look at the y value of this triangle, and the y value is 1/2. Okay, so now that I have the coordinates, I need to make sure that I'm using the right signs. So in the first quadrant, I need to have positive comma positive, and I do. Both of these values are positive. So we're good to move on. Now, another example of an angle that would use 30 degrees as a reference triangle would be the angle of 5 pi over 6. Okay, so at 5 pi over 6, if I were to graph this, let's say this is my angle of 5 pi over 6. Here's my initial side, and here's the terminal side, right? The reference triangle that's created would be the one that I have pictured on screen. And so I use a 30, 60, 90 triangle with the given sides. And to find cosine, I'm going to use x. And to find sine, I use y. So the cosine value along the x-axis of this triangle is radical 3 over 2. And the sine value, which is the y value, is 1/2. Okay. Now again, we need to make sure that we are using the correct signs. So in the second quadrant, I need negative x, positive y. So my cosine, the x value needs to be negative, and my sine is positive, which it is. So that would be my final coordinate for this location on the unit circle. Now, these reference triangles can also be flipped upside down to be able to give us the coordinates for the angles that are pictured below. So here I would have 7 pi over 6 and 11 pi over 6. Okay, and again, the same values are on my triangle, maybe just in different orientation because they flipped downward. And so it's a little bit repetitive, but here we go. To find cosine, I need the x value, which is radical 3 over 2. And to find the sine, I need the y value, which is 1/2. So radical 3 over 2, 1/2. And according to my signs, both the x and the y need to be negative in this quadrant. So I'm going to make this value negative and this value negative as well. Jumping over to the other side, 11 pi over 6. To find my cosine, cosine is x and sine is y. Oops, sine is y. So the cosine, the x value along the x-axis is radical 3 over 2. And the sine value along the y-axis, parallel to the y-axis, is 1/2. And according to my signs, which needs to be negative, the y value needs to be negative, so the 1/2 becomes negative. And those are the final coordinates at these angles. And the same can be done for a 45, 45, 90. So the angles that use 45, 45, 90 as a reference triangle would be pi over 4, 3 pi over 4, and we'll look at the ones that are below the x-axis in a little bit. So at pi over 4, again, I'm going to repeat the same thing. Cosine, I need the x value, which is radical 2 over 2. And for sine, I need the y value, which is radical 2 over 2. And I need to make sure that in this quadrant, both are positive, which they are. Moving on. For cosine of 3 pi over 4, I need the x value, which is radical 2 over 2. Then I need the y value for sine, which is also radical 2 over 2. And in this quadrant, only the first value, or the x, needs to be negative. So those would be my final coordinates for pi over 4 and 3 pi over 4. If I were to flip these downward, I could see that I can use these reference triangles for the angles of 5 pi over 4 and 7 pi over 4. Okay? And I'm just going to breeze through these because I've done a couple of these already. But for cosine, I need the x value, which is radical 2 over 2. And for sine, I need the y value, which is radical 2 over 2 as well. And in this quadrant, both must be negative, so I make each value negative. Moving on to the next side, for cosine, I need the x value, which is radical 2 over 2. And for sine, I need the y value, which is also radical 2 over 2. And here, the second value needs to be negative. The y value is negative. I need to do this one more time to get my pi over 3 values. So here is pi over 3 and 2 pi over 3. And same thing, to get cosine, I use the x. And to get sine, I use the y. Both are positive in the first quadrant, so I can leave my answers that way. To get cosine in the second quadrant, I use the x value. And to get sine, I use the y value. And in the second quadrant, the first value must be negative, so that 1/2 becomes negative. If I flip these triangles downward, this is what I get, and these would be the angles of 4 pi over 3 and 5 pi over 3. To find the x coordinates, I use my 1/2 value since it's parallel to the x-axis. And to find the y value, I use radical 3 over 2. That is parallel to the y-axis, and both must be negative in this quadrant. Lastly, I have 5 pi over 3. The cosine is 1/2. And the sine is radical 3 over 2, making sure that my second value is negative. And so if I were to get all of these coordinates that I just created, meaning if I were to get this coordinate and this one, and this one, all of these coordinates in different places, and copy and paste them exactly where they're supposed to be, but on the same unit circle, I would end up with this beautiful masterpiece of all the individual angles and the coordinate that matches at that specific angle. Okay? And so this would create the entire unit circle. And so really, you don't need to memorize the unit circle. You could always create your reference triangle and figure out what the sine and cosine is given the x and y values. I hope this video was helpful, and thank you so much for watching.